So when we say exponential function, okay, with a base b, if b is greater than 0 and b is not equal to 1. Okay? So the exponential function defined as f of x is equal to b raised to x. Okay? F of x is equal to b raised to x. So that is exponential function. So exponential function with a base b, if b is greater than 0 and b is not equal to 1. So we define exponential function as f of x equals b raised to x. Okay? So our first topic is how do we graph exponential function? Okay? How do we graph? So how do we graph? I'll just make it simple for you. How do we graph exponential function? Okay. So for example, y equals 2 raised to x, or f of x is equal to 2 raised to x. So how do we graph this? Okay, first we need to look for a horizontal asymptote. When we say horizontal asymptote, you're referring to the constant. Okay, constant you see in the given function. Okay, in the given function. So when we say HA, horizontal asymptote, you are referring to the constant that you will see in the given function. So in this example number 1, y equals 2 raised to x. Can you see a constant in this particular example? Can you see a constant? What will be the constant here in this particular example? What is the constant? What is the constant? What? Constant, constant. You're referring to a number. Constant. You're referring to a number. So what is the constant here? So the constant here is 0. Okay? So the constant here is 0. Okay? So when we say HA, you're referring to a horizontal asymptote. When we say horizontal asymptote, constant, number. Okay? A number you see in the given function. Okay? A number you see in the given function. So that is horizontal asymptote. Okay? So that's horizontal asymptote. So in this particular example, the horizontal asymptote is 0. Now, the question is, Miss, how do we plot that? Okay? How do we plot that? Okay? You can plot this exponential function, okay, by equating your exponent into two numbers only, 0 and 1. 0 and 1, okay? Just to make it simple to you, just to make it easy. So equate the exponent to 0 and 1, okay? So we have x is equal to 0, and then x is equal to 1, okay? So equate the given exponent to 0 and 1, and then assign values of y, okay? So your assigned values of x is 0 and 1, so you can always use that, 0 and 1, in graphing an exponential function, so it will be easy for you, okay? If x is 0, what is the value of y? If x is 0, what is the value of y? If x is 0, what's the value of y?
1.
Okay, 1. Why is it 1, my dear? Why is it 1? What's the concept behind that? Why is it 1? Why is it 1? Because, what's the reason? What's the reason? Why is it 1? Because any number raised to 0, the answer is always 1. Okay, yeah, very good. So any number raised to 0, the answer is always 1. Next, what about 1? If x is 1, what's the value of y? If x is 1, okay, 2, very good. Okay, well, see, you already have ordered pairs. 0, 1, 1, 2. And then you can now plot. Okay, so draw a Partition plane. First, you need to plot your HA, which is your horizontal asymptote. So your horizontal asymptote is 0. So meaning your x is 0. Okay, your horizontal asymptote, this one. Yeah. And then you plot the first ordered pair, 0 and 1. So 0 and 1. Okay, next, 1, 2. So we have 1 and then 2. Okay. Then you connect the dots. Okay, you connect the dots. Starting with the horizontal asymptote. So that is the graph of exponential function. Now, how do we determine the domain and range? So to determine the domain and range, look at the given graph. So what have you noticed? For the domain, could be anything in x values. For the domain, could anything on the x values? Is it? Could anything on the x values? Okay, yes po. So therefore, your domain is negative infinity to positive infinity. What about the range? What about the range based on the graph? What about the range based on the graph? Pertaining to the y values. What is the minimum y value here? Based on the graph. Okay? Okay, very good. So that will be 0 going up. So that will be 0 from positive infinity. So 0 from positive infinity. Okay? 0, parenthesis, because 0 is your asymptote. Okay? It's not included. That's your horizontal asymptote. So that will be 0 to positive infinity. So that's how we graph exponential function. Another example. Okay? Another example. So it's really easy. Another example. Let's say example number 2. The given is f of x is equal to 3 raised to x plus 1 minus 2. Okay? So the given is f of x is equal to 3 raised to x plus 1 minus 2. First, replace f of x by y because they are the same. So y is equal to 3 raised to x plus 1 minus 2. Now what's next? Identify your horizontal asymptote. So what is your horizontal asymptote? When we say horizontal asymptote, you are referring to the constant in the given function. So in this given function, what is the constant? What is the constant in the given function? Okay, very good. Negative 2. Okay? So that's it. Okay? Now next, miss. We need to come up with a table. But the problem is, what particular values of x? What particular values of x we need to use? Again, second procedure, after we determine the horizontal asymptote, which is your constant in the given function, equate the exponent to what? Equate the exponent to 0 and 1. Okay? 0 and 1. So we have x plus 1 equals 0. And then x plus 1 equals 1. Okay? So that's the second procedure. Equate your exponent to 0 and 1 to determine what value of x we need to use. Okay? So if x plus 1 equals 0, what is the value of x? X plus 1 equals 0 is the value of x. Okay, negative 1. Okay, good. Next. X plus 1 equals 1. X plus 1 equals 1. What is the answer? X plus 1 equals 1. What is the answer? X plus 1? Okay, 0. Very good. Okay. So meaning, we will be using negative 1 and 0. So negative 1 and 0. So we have negative 1 and then 0. Okay? So we will be using negative 1 and 0. Then after that, you substitute. So if x is negative 1, what is the value of y? If x is negative 1, just simply substitute. So what is the value of y? If x is negative 1, what is the value of y?
Negative 5 thirds.
If x is negative 1, substitute. So that will become 3 raised to negative 1 plus 1 minus 2. Negative 1 plus 1, what is the answer? Negative 1? Okay, 0. What is 3 raised to 0? What is 3 raised to 0?
0.
Oh, 3 raised to 0.
1.
Okay, 1. Okay, so 3 raised to 0, that is 1. So 1 minus 2. 1 minus 2. Okay, negative 1. Okay, remember, any number raised to 0, the answer is always 1. Okay, any number raised to 0, the answer is always 1. Okay, next. If x is 0, what is the value of y? If x is 0, what is the value of y?
Positive 1.
The answer is?
1.
Okay, 1. Okay, how to get 1? How to get 1? How to get 1? Because if you substitute 0, this will become 0 plus 1. 0 plus 1 is 1. So that will become 3 raised to 1. And what is 3 raised to 1? 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 Okay, 3. So 3 minus 2? 3 minus 2?
1.
Okay, 1. Okay? Can you still follow? Can you still follow? Is it easy? Okay, next. So after we come up with a table values and a horizontal asymptote, you can now plot the given points. Okay? So sketch the graph now so that your horizontal asymptote is -2. So we have 1, 2. Okay? So this is your horizontal asymptote, your -2. Next, you plot the given ordered pair. So we have -1, -1. So -1, -1. So here, 0, 1. So 0, 1. Okay? So how do we graph exponential function? So to graph an exponential function, so from the horizontal asymptote, okay? So from the horizontal asymptote, and then you connect the dots. Okay? So from the horizontal asymptote, going up. So therefore, what is your domain in this particular example? What's the domain? Obviously, the domain of an exponential function is always what? Always what? Okay, set of real numbers, so that will be -infinity to +infinity. But what about the range? So your range will vary in the given horizontal asymptote. So in this particular, what is your range? What is your range based on the given graph? What's the range? Okay, very good. So we have -2 to +infinity. So -2 to +infinity. Is it clear, people? Is it clear? Is it? Okay, next. What if the given is natural log? Okay. Means, what do you mean by natural log? How do we graph that? And what do you mean by natural log? When we say natural log, you're referring to E. Okay? You're referring to E. So natural log, I mean a natural exponential function. So natural exponential function, you are referring to E. So f of x is equal to e raised to x. So that is the natural exponential function. F of x is equal to e raised to x. So that's natural exponential function. Okay? F of x is equal to e raised to x. Okay? The natural log is ln. But since we're talking about exponential function, the natural exponential function is e. Okay? So how do we graph a natural exponential function? Okay? So how do we graph a natural exponential function? So for example, let's say the given is y equals e raised to x minus 1. Okay? So this is an example of a natural exponential function because we're using e here. Okay? So same concept in graphing exponential function. Okay? So first we need to look for a horizontal asymptote. If we're talking about exponential function, there's always a horizontal asymptote. Okay, it's constant. There's always a horizontal asymptote. So in this particular example, what is your horizontal asymptote? Okay, -1. Okay, very good. Next, what's next? After we determine the horizontal asymptote, equate your exponent to two numbers, 0 and 1. Okay, so equate your exponent to two numbers. Okay, 0 and then 1. So therefore, the values that we need to use to represent x will be 0 and 1. Okay? So the second procedure, equate your exponent. Okay? Equate your exponent to 0 and 1. Okay? To determine what particular values of x we need to apply or we need to use. Okay? So same concept in exponential function. Okay? Now, let's proceed. Substitute. Okay? So e raised to 0, take note of this. Okay? E raised to 0 is always 1. Okay? And then e raised to 1. What is e raised to 1? E raised to 1, there is a value. Okay? Using your calculator. So the value of e raised to 1 is 2.7. Okay? 2.7. So e raised to 0, again, that is always 1. And then e raised to 1, which is e, and there's a corresponding value of e using the calculator, and the value of that one is 2.7. So it's constant, okay? So yun yung laging value ng e, 2.7. So now, you can substitute, okay? So if x is 0, so meaning e raised to 0 is 1. So 1 minus 1, what will be the answer? If x is 0, substitute. If x is 0, so that will become y is equal to e raised to 0 minus 1. What is e raised to 0? What is e raised to 0?
0 po.
What is e raised to 0? What is e raised to 0? Take note of this. What is e raised to 0? Okay, 1. So that will be 1 minus 1. So what is 1 minus 1? 0. Okay, next, substitute. If x is 1, okay, you substitute. So if x is 1, so you do have y equals e raised to 1 minus 1. But what is e raised to 1? Take note of this. E raised to 1 is 2.7 minus 1. So what is 2.7 minus 1? What is 2.7? Okay, that will be 1.7. Okay, so you do have 1.7. Then after we come up with x and y values, you can now plug. Okay, so same thing. Same procedure in exponential function. Okay, same procedure. So you plot your horizontal asymptote, which is negative 1. So negative 1. Okay. Next, 0, 0 here. Next is 1 and 1.7. So 1 and then 1.7. Okay. So more or less here. Between 1 and 2. Now, how do we graph it? So to graph exponential or natural exponential function, so start with the horizontal asymptote. Going there. So that is the graph of this natural exponential function. Now, based on the graph, what is your domain? So same thing, when we say exponential function or natural exponential function, the domain is always the set of real numbers. So therefore, your domain will be from negative infinity to positive infinity. And then for the range, it will vary, depends on your horizontal asymptote. So in this particular example, what is your range? What is the range? Based on the graph, what's the range? What's the range based on the graph? What's the range?
0 to
What is your horizontal asymptote?
negative 1 to positive.
Okay, negative 1 to positive infinity. So we have negative 1 to positive infinity. Again, your range will vary. Okay, you can identify your range based on your horizontal asymptote. Okay, so that will be from negative 1 to positive infinity. Okay, another example of natural exponential function before we proceed to logarithm. Okay, so just take note of this reminders. E raised to 0 equals to 1, and then e raised to 1 is 2.7. Okay, so another example. Let's say the given is y equals 3 minus e raised to x minus 2. Okay, y equals 3 minus e raised to x minus 2. Okay, first, identify your horizontal asymptote. So what is your horizontal asymptote?
3.
Okay, 3. Okay, again, when we say horizontal asymptote, you're referring to the constant. Okay, constant. Pure number, constant in the given function. Okay, next. After we identify the horizontal asymptote, what's next? Equate the exponent to?
2, 0.
Okay, 0 and 1. So we have x minus 2 equals 0. X minus 2 equals 1. Okay, so therefore, x will be 2. And then x will become what? 3. Okay, so we'll be using 2 and 3. Okay, so we have x and then y. So after we come up what particular x values that we need to apply or we need to use, okay, which is 2 and 3, you can now substitute. Substitute. So if x is 2, what is the value of y? If x is 2, what is the value of y? Okay, 2. Okay, very good. Next, if x is 3, what is the value of y? If x is 3, what is the value of y? Substitute.
0.2.
Okay, very good. 0.3. Okay. Okay, and then you plot it. Okay, plot. First, horizontal asymptote, 3. So we have 1, 2, 3. Okay, so this is your horizontal asymptote. Okay, next, 2, 2. So we have 1, 2 here. Okay, next, what's next? 3, and then 0.3. So 3. So 0.3, that is between 0 and 1. So 0 and 1. So more or less here. Okay. So how do we graph exponential or natural exponential function? Okay. From the horizontal asymptote. So that's it. Okay. So your domain, since the given is exponential or natural exponential function, So your domain is always set of real numbers. So we have negative infinity to positive infinity. And then your range, based on the graph, what is the range? Based on the graph, what is the range? You need to write first the minimum value of y. So we have negative infinity going to? Negative infinity going to? Okay, 3. Okay, so the range is from negative infinity up to 3. Okay, so in rewriting the range, you need to write the smallest value first. Smallest value up to the highest value. So we have negative infinity to 3. So that's how we graph exponential function and natural exponential function. Is it clear? Is it clear?